the well-known compound used by you in the laboratory is ammonia. In ammonia, 3 hydrogen atoms are there. If you are replacing one or more hydrogens from ammonia, you will get resulting compounds which are known as amines. So the present topic is amines. How are they resulted? Organic compounds are derived from substituting one or more hydrogens in ammonia by alkyl or aryl groups. One or more hydrogen atoms in ammonia replaced by alkyl group or aryl group, then the resulting organic compounds are called amines. This is the class. What is the general formula to amines? These are represented by a general formula CnH2n plus 3n. Yes. What is the N here? N is the heteroatom you are watching in the present class amines. Right. This is the general formula for saturated amines, not for all classes. Saturated amines are represented by a general formula. Then come to replace one by one hydrogen from ammonia. What are resulted? Yes. So from ammonia, one hydrogen is resulted, you will get R and NH2. Two hydrogens are removed, and what will happen? Then you will get NH. Those two hydrogens replaced by alkyl group. Third hydrogen also replaced by alkyl group. Then 3 alkyl groups with 1 hydrogen. As number of alkyl groups increase, number of hydrogen H atoms are decreased. This is a simple way to take this one. Not only alkyl group but also aryl group. Aryl group is nothing but C6H5. Then how is it? We have to write like this. Better to write aryl group Ar2 and Ar3. Then very simple to classify the available amines as primary amine. Primary is given by, that is 1 degree amine, primary amine, shortcut, no need of writing the spelling primary, 1 degree have to write. This is secondary amine based on 2 alkyl groups attached to N atom. This is secondary amine. And 3 alkyl groups are attached. It is known as tertiary amine. And these are also classified as aliphatic amines with alkyl group, aromatic amines with benzene ring, and this is another classification. Then, based on, in case of secondary and tertiary amines, based on nature of alkyl group, same groups are attached and different groups are attached to an atom. And in that case, the classification is known as simple amines. And other class is mixed amines. How do you understand these two? Very simple. Simple amines example, and you have to write CH3, 2 or 3 attached to an atom. And in this case, CH3 attached to nitrogen atom, and nitrogen atom is also attached with C2H5. How are these 2 alkyl groups? These are different, and here these are same. That's why simple amines and mixed amines. This is a classification. And come to occurrence. Yes, where are these available? These are available in nature. In nature, where are they available? in animals as well as in plants. Some plants produce compounds containing nitrogen with a ring, and this is known as alkaloid. And the alkaloid here example given is ephedrine. Then in human beings and some other animals, during fighting or quarreling with some other animals, the hormone secreted in our body is adrenaline. Biology students are very familiar with these hormones, adrenaline, noradrenaline, like that. This is one of the hormones secreted in animals. Yes. In this, these two compounds used in order to increase the blood pressure. So this is a pharmacological action possible to observe. Then these are naturally available. One is hormone adrenaline, another one is alkaloid, and synthetically prepared one also there, that is novocaine. Artificially prepared in the laboratory, novocaine. Yes. What is the use of novocaine? Used as anesthetic compound in dentistry, dental treatment. Novocaine, anesthetic compound. Loss of sensation is possible by injecting the medicine into the body. Next, an allergy action is there. In order to reduce the allergic action, we have to use here one drug is given, that is Benadryl. Yes. And this knowledge, primary, secondary amines knowledge is applied on this area, and ephedrine and adrenaline contain which type of amine? Yes, these two contain secondary amines. Secondary amine. And these two are containing tertiary amine group. And other uses towards competitive examination is ephedrine, adrenaline used in increasing blood pressure, and ephedrine is plant origin alkaloid, adrenaline is a hormone secreted in animals, also known as flight hormone. Novocaine, synthetically prepared anesthetic compound in dentistry. Benadryl is antihistaminic drug in order to treat allergic actions, anti-allergic drug. This introduction helps you in competitive examinations. The heteroatom in amines, how is it detected? Yes, nitrogen is detected by which test in amines? That is Lassigne's test. As you have to recall, only for competitive point of view, carbon of organic compound, nitrogen of organic compound with a sodium metal, that is a sodium fusion extract you will get, and nitrogen in organic compound, a covalent compound converted into ionic compound NaCl. Now, what are the reagents used? First, this is added with ferrous sulfate, and it is converted to finally Na4FeCN6. After that, what is the reagent you have to add is ferric chloride. You will get a blue color. That blue color is Prussian blue. This is for competitive point of view, either NEET or JEE. Yes. The heteroatom present in amines detected by which test? And how is the color observed in sodium fusion extract? What are the reagents added? These are first ferrous sulfate is added and heated. Then the compound, after formation of a complex compound, that is finally treated with a ferric chloride solution, you will get Prussian blue. Prussian blue formula you have to collect. That is your industry to collect the information from previous year things. So this is now classification. Yes. How do you classify amines? Based on number of alkyl groups attached to nitrogen atom, N atom, that is RNH2, a primary amine, secondary amine R2NH, tertiary amine R3N. Yes, this is a very less important area, mixed amines and simple amines. But this is not that much useful to ask a question in the examination, only for a knowledge purpose it is. And these things are available, useful in case of competitive examination. And one more competitive examination is sodium fusion extract that you have to use. Clear? Okay. Shall we move to next topic of amines? Introduction is over. From introduction, the possible questions are general formula for saturated amines. CnH10 plus 3 N. The heteroatom N is detected by which test? That is competitive point of view. And PU point of view, what is the general formula of secondary amine? You just write R2NH or AR2NH. Don't write AR2 by R2NH. Either R2NH or AR2NH you have to write. I hope you understood this area. Very simple and small information possible to ask from this area towards examination. Right. Come to the next area, name. Naming is very, very important. Two names are there, nomenclature. One is nomenclature you are taking. Common name, IUPAC name with structures. Yes, IUPAC name for what purpose? That is, whatever the area, if the student is moving, but the name of the compound is not changed, uniform name is present throughout the world. That is the main aim of International Union of Pure and Applied Chemistry, and the type of nomenclature is IUPAC nomenclature. And this is compound is here taken, and I have to use main saturated hydrocarbons. Few other examples will be taken. The first member of saturated hydrocarbons with the formula CnH2n plus 3n. Okay, then N is 1, you will get CH3NH2. In what style you have to name as common name? Just name of the alkyl group, that is alkyl, and suffix is amine, and the rhyming word available is alkylamine. But in IUPAC name, how do you name? How many carbon atoms in the longest chain is given by alk, number of carbon atoms given by alk, and the nature of carbon chain generally single bond AN, and NH2 is the functional group denoted by secondary suffix amine, and the rhyming word available is alkanamine as methanamine, ethanamine, propanamine, butanamine, etc. Clear? Yes, it is. CH3 is named as methyl, and the suffix is amine. Methylamine is which name? Common name. IUPAC name is one carbon chain, that is meth, and the superprimary carbon always AN, methane, and NH2 is denoted by amine, and its name is methanamine. Come to a molecular formula C2H6 plus 3 9, 2 2s are 4 7, C2H7N. With this formula, what are possible? I have a chance to distribute these atoms and write two different structures, that is CH3 CH2NH, CH3 CH3. These two are attached by NH. Yes, if NH2 is present, recall the previous knowledge we gained, that is primary amine. NH is present simultaneously, two alkyl groups are attached, and that is also an observation, not simply blindly NH. NH with two alkyl groups, this is indirect observation, secondary amine. Now come to C2H5 is given by ethyl, and the suffix is amine. Clear? Now, this one is methyl, two times are there. Then how do you do? Just before alkyl, same alkyl groups, just you have to write the prefix di to denote the same substance, two types. That is methyl, and the suffix is amine, dimethylamine. And what is the new word here resulted when compared to previous case? Di, tri, type prefixes are used before alkyl if same alkyl group is attached. Different alkyl groups, that is a mixed amine, then you will write the name of the alkyl groups in alphabetical order. Next coming examples you will see very soon. Now, IUPAC name, two carbons in the longest chain, that is ether, single bonds are given by AN and NH2 is given by amine. Here, two carbons are not continuously attached. So one carbon is present and this is treated as one methyl group as substituent on nitrogen atom, another one as parent chain, and which is smaller one taken as substituent, and its name is, another style is N-alkyl. Because this group, alkyl group attached to nitrogen atom, that is N-alkyl, and how many carbons in the longest chain is alk and AN amine. It is another style as based on the nature of the alkyl group. Therefore, the substance present methyl on nitrogen atom N, and the substance is methyl. Very good. Then one carbon chain as parent chain with single bonds AN and amine is complete name I would like to read. You just follow, that is N-methyl methylamine is the IUPAC name of dimethylamine. And what you observe, formula is same and different structures, and you study in the first year structural isomerism as these two are different, and the type of isomerism, type of structural isomerism exhibited by these two compounds is, yes, what is your what the point you have to write towards isomerism? They have different functional groups. Even though amines, primary, secondary, tertiary amines collectively with the same molecular formula known as functional group isomerism. Functional isomerism is exhibited between by the pair of ethylamine and dimethylamine. Come to C3H9N. How many structures are possible? I would like to write bond line structure 1, 2, 3 carbons, and this is NH2. Another version is 3 carbons. You just write NH2 on middle carbon. If you write on another terminal carbon, it becomes, as per IUPAC nomenclature, it becomes first carbon, that is. And another structure is write 2 carbons and write N, 1 carbon other side. The last structure is N is attached with 3 alkyl groups, that is CH3, CH3, CH3. This is CH2, CH3, 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 CH3. Then come to how is the chain. Chain has normal one and attached to primary carbon. This is N-propyl amine. Clear? This is CH3, CH3. The group you discussed or previously learned as isopropyl group. Isopropyl or secondary propyl, both are same. Isopropyl amine. And here small information is available. This is CH3 methyl, and this is CH2 CH3 ethyl. And how do you name? Ethyl, methyl M, ethyl E. Alphabetical order you have to follow in common nomenclature. Therefore, that is ethyl first, methyl next, ethyl, methyl, and the suffix is amine. Now come to how many CH3 groups present on an atom? 3. So it is given by tri, and the common substituent is methyl and the suffix is amine. It is the knowledge in common nomenclature, but IUPAC nomenclature, come to this one. First time what is needed from the apart from the previous examples. Numbering is important. NH2 present on which carbon in the parent chain? Lowest sum role you studied, that is first carbon. So better to write this is number 1, number 2, number 3. Therefore, number of carbon atoms 3, single bonds given by AN, propane, and NH2 located, that is numerical locant on which carbon? First carbon 1, and that is given by secondary suffix amine. As the name is propane, 1 amine, 1 propanamine, propanamine 1. This is the way of giving nomenclature as IUPAC nomenclature. And how do you name this one? Propane, amine at which carbon? Second carbon, propane 2 amine. You just write with your knowledge. Now come to this one. As between two alkyl groups, which is longer? Longer one is CH3, CH2, and shorter one is this one. Shorter one taken as N alkyl, longer one is considered as parent chain. One of the rules you studied. Therefore, N methyl. 2 carbon chain is eth, single bonds AN, and amine as amine. Combine all these things and come to this one. How do you answer? 1 alkyl group as parent chain, 2 alkyl groups as substance. Therefore, it is repeated 2 times. N and N repeated, and how many times? 2 times dimethyl methanamine. Okay. Yes. What is the common rhyming word in a common nomenclature? Alkyl amine, methyl amine, ethyl amine, propyl amine, butyl amine, like that. IUPAC nomenclature is followed in which style? Alkanamine. Alkanamine is methanamine, ethanamine, propanamine, butanamine. As before amine, what is required? Where is it located? Numerical locant before the name of the secondary substance. 1 amine, 2 amine, 3 amine, like that. See this one, I didn't write the information. It is 1, 2, 3 or 1, 2, 3 from either of the ends. So it is propane 2 amine is the answer. Propane 2 amine. As if you are interested, what is available? How many structural isomers are possible with the molecular formula C3H9N is a question in front of you. How do you write this? Simple answer. That is 1 propanamine, 2 propanamine, N-methylethanamine, N-dimethyl-methanamine. Final answer is 4. That is a possible PU question as well as competitive examination. Right. This N-methylethanamine is classified as which type of amine? Your answer is secondary amine. This tertiary, this is N-dimethylethanamine. Trimethylamine is classified as which type of amine? That is tertiary amine. So how many primary tertiary amines respectively possible with the molecular formula C3H9N is another question. Your answer is NH2, NH2 both are primary. 2:1:1 primary, secondary, tertiary in the ratio 2:1:1 with the molecular formula C3H9N. I hope you are better following this way, and it is not possible to ask questions by you and clarify your doubts. Okay, this is the drawback in this type of teaching. Thank you. If you are interested towards isomerism, from the previous formula C3H9N, and I would like to deviate from the nomenclature to another topic that is isomerism. Just a quick look at this one. Isomerism. Isomerism, the main satisfactory condition is molecular formula is same. Same molecular formula, different structures we are writing. Structural isomerism here only to be discussed with this one. That is, the formula is C3H9N. With this one, what are possible? Dear students, I would like to recall, just your observation is very, very important. That is NH2. This is another NH2. This is one and this is another one. Yes. After leaving, what is your observation? This is CH3, this is CH3, this is CH, and it is CH, CH3, this is CH3, this is CH3, CH3, and CH3. Yes, my opinion is here, my aim is to bring notice to your notice which type of structural isomerism is exhibited. 1 propanamine, 2 propanamine, this pair is known as position isomers. Positional isomers. Right. And structure 1 or 2 with structure 3. This is structure 1, structure 2, 3, 4. Yes, 1 and 3 are 2 and 3. 1, 3, 4, 2, 3, 4. This combination is known as different amines, primary, secondary, tertiary amines are known as functional isomers. Clear? Next one is that much only. 2 types of isomerism exhibited by these 2. Yes, one more thing not possible to take. Yes, only 2 things, that is positional isomerism and functional group isomerism exhibited by the molecular formula C3H9N. Total isomers are, yes, primary amines are how many in number? 2. Secondary amines are 1 and tertiary amines are 1 in dash ratio respectively, that is 2:1:1, only for competitive purpose, only for NEET or JEE, that you have to follow. CET, what is the name? Name is not important. CET, JEE and CET. Right, now move to another molecular formula C4H11N. C4H11N. Now you have to try nomenclature as well as structures you have to follow and observe the type of isomerism. Common name as well as IUPAC name with the molecular formula C4H11N. Cn H2n plus 3n. By using this formula, saturated amines are to be designed. N 4 into 2 8, 8 plus 3 11, enough, that is. Yes. The first one, without hesitation, just bond line structure is friendly to you to save time. 1 2 3 4 carbon chain, and I am interested to attach NH2 on first carbon. In the next case, NH2 on second carbon. Is it possible to write on third carbon? If it is on third carbon, from this end it becomes 2 as per IUPAC nomenclature. So only 2 possible with 4 carbon chain. 4 carbon chain now reduced to 3 carbon chain and 1 side chain, and attached nitrogen NH2 group on primary carbon. Then I would like to shift NH2 to middle carbon. This is a okay. After that, Better to write NH type compounds, means secondary amines. How do you distribute 4 carbons? 1 on one side, 3 on other side as CH2, CH2, CH3. You have another chance to write the same one. This is NH, CH3, and side chain is a little bit branched like this. CH, CH3, CH3. Clear? As what is another structure possible? Around nitrogen, 3 alkyl groups you have to write. That is a special one here. Around nitrogen, 3 alkyl groups. One is CH3. Another one is also CH3, but remaining 2 taken as parent chain CH2, CH3. How many are now available? Total 1, 2, 3, 4, 5, 6, 7. 7 are possible. 4. Yes, one more structure is possible with this formula. That is distribution of 2 alkyl groups in a different way. That is N, CH2, CH3 one side, CH2, CH3 another side. And H automatically to be taken. Yes. Now what is possible to observe? How many structures? 1, 2, 3, 4, 5, 6, 7, 8. As total number of isomers given in the textbook, solution you have to prepare as 8 structural isomers are possible. This is an answer to a question. Yes. Among these, how many primary amines? Blindly NH2 if present, a simple answer, simple prediction is primary amines 1, 2, 3, 4. 4 primary type. And how many secondary? NH is there, NH, NH, NH. 3 are there as 3 secondary amines. How many are tertiary? Tertiary is only 1, and total number of isomers are 8. Now come to common name and IUPAC nomenclature. What is the common name? This is which group? Butyl group, N-butyl amine. It is N-butyl amine. But in the examination, what is largely concentrated? IUPAC name. NH2 present on which carbon on the parent chain? 1, 2, 3, fourth carbon, or 1, 2, 3, 4, first carbon from both ends. 1 carbon is correct. This is the way of numbering to the parent chain. After numbering, in your mind, no need to mention on the board, only for understanding purpose. So it is but, single bond AN, and this is amine at which position? Amine at first position, 1 amine. Okay, so common name. Now, how to write this one? This group is called CH3, CH2, CH, CH3. This group is known as secondary butyl group. Secondary butyl group is attached with NH2. It is secondary butyl amine. Is a secondary butyl amine a secondary amine? Is a funny question. Is secondary butyl amine secondary amine? What you are watching? Here in this compound, nitrogen atom attached to only one group, one alkyl group, that is secondary propyl group, secondary butyl group. So it is a primary amine. What is the mismatching here? Secondary butyl amine is not secondary amine, but secondary butyl alcohol is secondary alcohol, whereas OH attached to secondary carbon, OH attached to tertiary carbon, OH attached to primary carbon. But here, even though N is attached to secondary carbon, but it is attached to only one alkyl group. That's why this secondary butyl amine is not secondary amine. That you have to keep in mind in a separate way. Now take this one, numbering from this end, 1, 2, 3. First substance, this is CH3 on which carbon, dear students? Second carbon, so it is 2. CH3 is given by the name methyl. Parent chain has 3 carbons. Single bonds given by AN, And where is the functional group attached on first carbon? 1, and NH2 is given by amine. Okay, right. Now see this one, same information, 2-methyl propane, but it is a same name, 2-methyl propane and amine. At which amine this is? 2-amine. Don't write like this in your examination, as here only I am possible. So in this case, 2 different alkyl groups. It is a mixed amine. Previously we discussed mixed amine. It is an example. In this case, longest chain is treated by this one, and it is numbered as like this 1, 2, 3. And this CH3 attached to nitrogen, not connected with carbon chain, separated. That's why it is treated as substituent. And common name is methyl N-propyl, MP. Methyl propyl amine is the common name, and IUPAC name is. Now take the IUPAC name, dear friends. That is N, nitrogen containing methyl group, N-methyl, propane, 3 carbon chain prop, single bond CN propane, and where is a functional group attached on first carbon? 1 amine. Here how do you name numbering? Numbering is not from this one, it is middle carbon. Starting from one end to another end. Move to one end to another end. Then same story, N-methyl propane. Yes, NH2 group attached to which carbon? Second carbon. This is 2-amine. These 2 are classified as secondary amines. One more secondary amine here available. And how many ethyl groups? Ethyl, 2 ethyl groups. Its common name is di-ethyl amine. Clear? Okay. Now, common IUPAC name is, this is a parent chain treated as, and that one is substituent. Substituent present on an atom N. The name of the group is N-ethyl. This is N-ethyl, and it is 2 carbon chain with single bonds AN, and the primary suffix is amine. Before amine, no need to write the number. That is 1, always 1. Now come to the last structure, what you are watching. This is parent chain, and these 2 are substituents. Same substituents present on N atom. So you have to repeat N atom. N-methyl, N-methyl. That's why N, comma N. Methyl, methyl 2 times di. CH3 is methyl. And the last one is 2 carbon chain ether, single bonds AN and amine. Yes. Before concluding nomenclature, as what are other aspects from this structural formula, from this molecular formula and the different structures? Yes, some answers are available. How many structural isomers are possible? And your answer is 8 structural isomers are possible. Among these, how many primary, secondary, tertiary? 4 primary, 3 secondary and 1 tertiary. Then their nomenclature, names are here available. You have to practice. After that, optically active compound means it should has chiral carbon. Chiral carbon means carbon attached with 4 different groups, and it has non-superimposable mirror image. That you studied in haloalkanes and haloarenes chapter largely, and the knowledge is going on in other topics. So therefore, this secondary butylamine, nothing but yes, its name is butane 2-amine. Butane 2-amine is optically active, and it has non-superimposable mirror image. Among these, any other with a different alkyl groups attached to carbon atom, different groups attached to carbon atom? No. In any other compound, it is not observed. Only one is among the following which is optically active may be given, and names are given: 1 butanamine, 2 butanamine, 2 methyl, 1 propanamine, 2 methyl, 2 propanamine, like the different names possible to give you. Your answer is 2 2-butanamine or butane 2-amine. Okay, isomerism. This is structure 1, structure 2. Yes. I would like to write this is structure 1, structure 2, 3, 4, 5. No. This is 5. This is 6. This is 7. And this is 8. Structure 1, 2, 3, 4, anyone you have to take and compared with 5, 6, 7 or 8. 5, 6 or 7 from this 3, 1 and 8, and that is 1, 2, 3, 4. From this one you have to select. Then 5, 6, 7. From this 1, 1 and 8. Yes. These 3 compounds are 2 compounds. This is compound 1 from this group compound 1, from this one compound 1, and the type of isomerism between primary, secondary, tertiary amines is functional isomerism. Okay, that is over. Now come to 1-butanamine and 2-butanamine. Position of functional group is changed. This is positional isomers. 1, 2 are positional isomers. 3 and 4 are positional isomers. Why? Because 2-methyl 1-propanamine, 2-methyl 2-propanamine. So these 2 are also chain isomers, chain of the carbon, chain of the alkyl group is different. That is. Now come to 5, 6 and 7. 5, 6, 7. What is the type of isomerism exhibited? 5 or 6 equivalent with 7. This is known as metamerism. Different alkyl groups attached to divalent functional group. Different alkyl groups attached to divalent. No need of writing definitions here, just recognition. And this is. And the third one is metamerism over S. How many types of structural isomerism possible? With a C4H11N, chain isomerism, position isomerism, chain isomerism between 1 and 3, or 2 and 4. 1 and 3 or 2 and 4. This is chain isomerism, position isomerism, next metamerism, functional isomerism. So how many types of structural isomerism exhibited by this one? So your answer is 4 types. Along with what is the stereoisomerism exhibited by one of these compounds, that is optical isomerism by butane 2-amine. Few examples are left given in the text. Apart from single bonds, first time we are experiencing with going to have experience with double bond in the given structure. The well-known group you studied is CH3, CH, double bond CH, NH2. What you are watching, dear students, the nature of carbon chain is double bond. This is a different one. I am not interested like this. This is CH2, CH2, and here I would like to write double bond. Yes, no problem. And this is NH2. Yes, what is the group you are studied? This one. What is the group you are studied? The group you are studied as allyl group. Okay, it is allyl. Allyl, and this is NH2amine. What is IUPAC name of allyl amine? Sometimes may be given, or draw the structure of allyl amine for PU examination. So your answer is this one, and numbering is like this: 1, 2, 3, and nature of carbon chain: 3 carbons prop. Single bonds are given by, double bond is given by in at which position? Second position, that is 2 En, and functional group present on first carbon 1 amine. How do you rewrite in a different style? in competitive examination. This is joined as 2 propene, and this is joined like 1 amine. Also correct name. Both are correct names and both are also common names. Sorry, IUPAC names. Common name is allylamine and IUPAC name is this one. And if you are interested, type of hybridization. Yes, this single bonded carbon atoms is sp3, this is sp2, this is sp2, and as usual nitrogen, it is sp3. Yes. Come to another example, that is with benzene ring. Only textual examples I am discussing, not lengthy examples, no need to take here. At any one corner, you just write NH2 is classified as NH2 primary amine, and that NH2 attached to which ring? Benzene ring, and it is aromatic primary amine, very very important. Previously this is a aliphatic primary amine and especially allyl amine. This is allyl amine, not aliphatic one. Now come to, sorry, not aliphatic, yes, aliphatic unsaturated this is. And the well-known common name is aniline. This aniline is also accepted as a IUPAC name. Along with that one more name is suggested, that is benzene amine. Benzene amine. But largely we are discussing with only aniline as common name as well as IUPAC name. Sometimes to confuse the student, what may be given? Benzene amine is given. This is CH3, benzene with the CH3 you studied as toluene and NH2, and the position is alternate position, which is given by ortho. Toluidine. Toluene and aniline both are mixed. Toluidine is, and the IUPAC name is, yes, this is taken as parent 1 NH2 as substrate, that is at second carbon 2 amino methyl benzene is known as toluene. Okay. Like that, we have to change the position, meta position, alternate positions, opposite positions, pair of positions. You will take that one. Yes. This is the end of nomenclature. After that, what is the structure of amines? As amines are the parent compounds of ammonia. As ammonia has 1 lone pair and 3 bond pairs. So topic is structure of amines. Just 2 points I would like to recall. As ammonia, very familiar to you as pyramidal structure, and amines also exhibit pyramidal structure. Why? Because the central atom is nitrogen. So nitrogen atom undergoes sp3 hybridization, and in amines on nitrogen atom what are present? Lone pair electrons are present. Hence the shape is pyramidal, sp3. And what is the bond angle you are observed? You are observed that is less than 109 degrees, 28 minutes, 109.5 degrees. While less than tetrahedral bond angle due to repulsions between lone pair and bond pair repulsions. These are for sometimes PU and sometimes competitive examination. So what is the structure of amines? Pyramidal. Nitrogen atom undergoes which hybridization? sp3. And how is the bond angle? Equal to 109.5 degrees, more than 109.5 degrees. Cannot be predicted. So less than 109.5 degrees. Why? Answer is between repulsions between lone pair and bond pair electrons. This is a story related to introduction, related to amines as introduction, nomenclature, structure, isomerism. 4 points I covered. I hope you better understand this one. Thank you very much.